Okay, so one of the things you have to be able to do on your final is to add and subtract polynomials. Okay, add and subtract polynomials, and in order to do that, you need to know what like terms are. Now, you know what like terms are. You've solved equations before. You've solved inequalities before, and all those involve like terms. So this is going to be number 4, and that's on page 918. All right, it looks like this. You have this polynomial, 3x minus 8. So usually what happens is when you're adding, subtracting polynomials, they'll put the polynomials in parentheses. And so you have this polynomial, which has how many terms? Because in one of the videos you talked about terms. How many terms does this polynomial have? 2. What are they? 3x is the first one. What's the other? Negative 8. Okay? All right. And then you're going to add that to this polynomial. Before I go on, this polynomial, that first polynomial, it has a special name. Do you remember what that name is? A binomial, by 2. And it's being added to this polynomial, which is 4x squared minus 3x plus 3. Now, this polynomial has how many terms? 3. So it's called what kind of polynomial? A trinomial. It has 3 terms. And each of those terms are monomials. I'm sorry? Zoom in? Probably the light's not on. I mean, usually the light comes on. Let me try it again. All right, so we're adding these 2 polynomials. Probably made it worse. Okay, so, all right, so in order to add polynomials, these 2 polynomials, you're going to combine like terms. So if you go back to that first polynomial, that first term is 3x, okay? And so like terms are terms that have the same variables raised to the same power. The corresponding variables have the same exponent. So this term that I'm looking at only has how many variables in it? Variables. 1, the variable x. It has what exponent? 1. If I go to this polynomial, do I have a term that I can combine this with? Yes. Is it this one? No. These are unlike terms because the exponents are different. But it's this one, right? Okay. So what I'm going to do is just underline these. Adding is the easy kind. I'm going to underline these to indicate that those are the ones I'm going to combine. And basically you're adding, see, you're adding the coefficients. What's 3x and a negative 3x? What's 3 plus a negative 3? 0. All right, so that term goes away. All right, so then I'm going to go to the next term, which is the constant, negative 8. Is there another constant anywhere in the other polynomial? 3. Yes. What's a negative 8 plus 3? It's 5, right? So when I add these 2, I'm going to get 5. So I have 5. All right, now the only other thing that's left is what? 4x squared. So I have 5, these 2, plus 4x squared. Now, yes, I'm sorry. Yes, thank you. All right, now they're going to ask you to put this in descending order. Descending order. So that's one of the words that you saw. Descending order, if you're in a plane and you're descending, you're going from a higher altitude to a lower. So descending order means to put the polynomial from larger exponent to the smallest. So how many terms do you see here? 2. Your constant always goes to the end. So what's going to be the answer in descending order? 4x squared minus 5. See, there's no x term, because why is there no x term? Because the coefficient is 0. 0 times x is 0. You don't write it. All right, so that's number 4. Let's look at this one. So I'm going to write this example. So suppose we had 6x squared minus 4y plus 7, and I'm adding this polynomial to this one. I did not mean that to be two different variables. I'm sorry. Let's make that x. Okay. So I'm adding these two polynomials. That's an x, negative 4x. All right. And let's go ahead and start talking about, let's put in descending order. So I'm putting descending order. X to what power is going to have to be listed first? X to what power? Second. X to the second. I do have an x to the second. There's this one. Can I combine it with something else? Yeah, negative 2x squared. Those are like terms. So what's 6 and a negative 2? 4. So it's going to be 4x what? Squared. So I get 4x squared. All right. So that takes care of this x squared. Now the x's. There's this one. Is there another I can combine it with? Yes. So what's a negative 4 and a positive x? Minus 3x, right? And then the only thing left is the term, and what's that term called? Constant. So what's a positive 7 and a negative 1? Positive 6. Okay? All right, so the adding polynomial with just one variable is the easy kind. Okay? Now, let's suppose you are adding with, let's say, there's really none in this section. It's not on your final. But I'm going to go ahead and make this up. Suppose I had this, just to see if you understand what like terms are. 2x squared y, okay, minus 7xy plus 8y minus 2 plus, write this down. Now, a polynomial with 4 or more terms, does it have a special name? No. Only 2 terms, 3 terms, and even 1 term. 1 term is called a monomial. So you have a monomial, a binomial, and a trinomial. So let's suppose we had 4xy plus 7x squared y. And I'm running out of room, so I'm just going to make it a trinomial, minus 6. Okay, now you see I have 2 different variables here. So don't worry about putting descending order. Normally when we put a polynomial in descending order, it's only with 1 variable. This thing has 2 variables, so it doesn't matter how you write the answer. Let's just start with the first term you see. What's the first term you see? 2x squared y. All right, so you want to combine it with another term that has what variables in it? X, y, and x has to be raised to the second power. Do I have that? Yes. So I can combine this one with this one. Remember, you're adding. So what's 2x squared y plus 7x squared y? 9x squared y. All right, now let's go to the next one. I have an xy. Do I have an xy anywhere else? Right here. So what's a negative 7 of them and a positive 4 of them? Negative 3xy. Good. And then let's do the y. I have an 8y here. Do I have another y anywhere? Nope. So you just rewrite it. All right. And then negative 2 is my constant. Can I combine it with something else? Negative 2 and a negative 6 is a negative 8. So there's your answer. All right. So that's adding. Now let's talk about subtracting. Okay. So when you subtract, remember, when you subtract, you want to remember the idea of adding the opposite. So one of the things that some of you, even though I told you not to do this on the videos, even though I said that, some of you still do this on your test. When you wrote those equations of lines, if you see y minus a negative 6, what should you write this as? Y plus 6. Because remember, you always want to change the subtraction. What kind of problem? What kind of operation? Addition. So it's always add the opposite. So it becomes y plus, and what's the opposite of a negative 6? Positive 6. Okay, so you can use that idea with what we're about to do. You also remember something from test 1 probably. How would you handle this? A negative 2 times x squared minus 6x plus 1. How would you handle that? Use the distributive property. So what's negative 2 times x squared? What's a negative 2 times a negative 6x? Positive 12x. And what's a negative 2 times a positive 1? 2. Okay. You also learned this in a previous lesson. What if you had negative 1 times 7xy plus 3x minus 4? What would you distribute? Negative 1, right? So it's negative 1 times a positive 7xy. What's a negative 1 times a positive 3x? What's a negative 1 times a negative 4? Okay. Now what if you had this? Let's see if you remember something. What if you had this? Okay, so you can think of this as negative 1. Very good. So you just distribute the negative 1 through here. So that becomes negative 8x. 4y? Yeah. Minus 7. Okay. All right. Now let's look at this. Okay, now we're going to talk about subtracting polynomials. So we know how to add. We know how to add. Let's talk about subtraction. So let's suppose we had this. We had 7x minus 6. That's my first polynomial. That's a binomial. And I'm subtracting this polynomial. And let's say that polynomial was 5x plus 4. All right, so I'm subtracting, right? So a while ago we talked about always changing subtraction. What kind of operation? Addition. All right, and so you can think of it that way. You can also think of it this way. If I cover this part up and I want to get rid of the parentheses, I could just distribute a what? Negative 1. That's what you're doing. Okay? So there are multiple ways you can think of this. So that first parentheses I can just remove. Okay? Because that's what number out here? A 1. 1 times anything is itself. Now let's go ahead and get rid of that second parenthesis. So you can think of this as adding the opposite or just distributing a negative 1. Okay? So when I add the opposite of all of these, what do these terms become? What does this become, guys? Minus 5x minus 4. So that's where I'm at. Okay? Now let's combine like terms. I can combine the 7x with the what? Someone said 5x. Is it 5x? It's negative 5x. Okay? Negative 5x. So what's 7x and a negative 5x? 2x. And then let's talk about the constants. That's the only thing left. What's a negative 6 and a negative 4? Negative 10. So there's your answer. 2x minus 10. Okay? Let's look at this one. Suppose you had, this is going to be number 18. It's 4 plus 5a, and I'm subtracting a negative a minus 5. 4 plus 5a, and I'm subtracting a negative a minus 5. So I'm subtracting, this is subtracting, I'm subtracting two polynomials. So we're going to change the subtraction to addition, and let's get rid of the parentheses. So I can get rid of this one. That just becomes what?
4 plus 5a.
Yeah, because that's understood to be a 1. 1 times 4 plus 5a is 4 plus 5a. And over here, let's think of this either as distributing a negative 1 or adding the opposite. With whichever one you use, what will this become?
Plus a.
Plus a plus 5. All right, and then let's combine like terms. What's the answer? And let's put in descending order since it's just one variable. How many A's? 6A plus 9. Okay. All right. Now let's look at this one. Yeah, always put the constant last. Put the constant last. Suppose we had, write this example, suppose we had negative 6y plus 5, subtract 3y squared plus 4y minus 1. So minus 6y plus 5, subtract 3y squared plus 4y minus 1. All right, so I'm subtracting these two polynomials. Let's go ahead and change it to an addition problem. So this becomes negative 6y plus 5. But what does that become? Minus 3y squared? Minus 4y plus 1. All right, all you just combine like terms, and let's put in descending order. So what's going to be listed first? Yeah, the y squared is going to be listed first, but there's only one term of y squared. So just write it first. So that's this one here. So that's negative 3y squared. All right, now the next one is going to be y. How many terms? There are two of them, right? So it's a negative 6 and a negative 4y. Negative 10y. And the only thing left are your constants. A positive 5 and a positive 1 is a positive 6. Okay? All right, now, let's talk about this then. If I said 8 subtracted from 10, don't tell me what the answer is. Tell me how you'd write it out first. How would you put that in your calculator if you were to use your calculator? What would you punch in first? You punch in 10 first. So subtracted from, you reverse it. Okay? So you're going to say 10 subtract 8, which is 2. So then, what if you had this? Six x minus 5 subtracted from 8x plus 1. Okay, so the one in your final is going to have some words. It'll be words like subtracted from.
8x plus 1.
So you can put 8x plus 1 first. Okay. So you're going to say that's going to be 8x plus 1, and then subtract in parentheses minus 5, and now that looks like the previous one. So on your final, you're going to see subtract from. So you put that second polynomial first, and then you say minus, and then the next one. And now you do what we just did. So change it, what kind of problem? Addition, right? So what would you write? 8x plus 1 minus 6x plus 5. All right, so it's kind of like just using distributive property or adding the opposite. Now what's the answer? 2x plus 6. Okay? All right, now let's look at another subtract from. Another subtract from. Okay, suppose you had negative 6x plus 5, subtracted from, that's from, subtracted from, and let's say it was being subtracted from 7x squared plus 5y minus 2. So negative 6x, that polynomial is being subtracted from the other polynomial. So you want to rewrite it. So what would you write first? 7x squared. So you write that second polynomial first. So that's going to be 7x squared. I didn't mean that to be 5y. I'm sorry. That was supposed to be what? 5x, excuse me. So plus 5x minus 2, and then minus what?
Minus 6x plus 5.
Yeah, and remember you put that in parentheses. So you keep the parentheses there. Okay, now what's the next step? Get rid of the parentheses, so that's going to be 7x squared
Plus 5.
plus 5x minus 2, and then
Plus
just
6x
plus 6x
minus 5.
minus 5. And then combine like terms, put in descending order. What's going to be the first term in your answer?
7x squared.
Okay, now the next term, the x's. There's a 5x and a what? 6x, so it's going to be a
11x
plus 11x. And then your constants,
minus 7.
minus 7. And there's your answer. Okay, so that's adding and subtracting. So if you can do the previous two you just did, then you'll get the one that's in your final. They always ask something like that. And that's 8 points. I'm sorry, 10 points. They're 10 points each. Okay, 10 points. So that'll be 10 points. Don't lose those 10 points. So if you can do something like this, you're fine. Okay, now let's talk about this idea that we had before. So if you have 3x squared times a negative 4x cubed, what is that?
Negative 12x to the 5th.
Yeah, negative 12x to the 5th. When you multiply like bases, you're using a product rule, right? Using a product rule with the variables. You just had it a couple of days ago on your test. So the product rule. So now you deal with the coefficients differently. You only use a product rule with the variables. So 3 times a negative 4 is a negative 12. And then x squared times x cubed, that's where you use a product rule. When you multiply like bases, you add exponents. What's x squared times x cubed? X to the 5th. All right, so that's something you had on your test. So then in particular, if you have 2y times 3y, then that's just equal to what? 6y squared. Okay? The exponents are understood to be 1. 1 plus 1 is 2. Okay? All right. So that's a review of what we're about to use now. So if I have this, and the direction is going to say something like perform the indicated operations. All right. So let's do this example. Suppose I had 3x times 4x squared minus 7x plus 1. Think about what we did a while ago, and then what we talked about here. So we get rid of the parentheses. So the operation that I need to perform is that multiplication, because this says 3x times what? This polynomial. So I have this monomial times this what? Polynomial, trinomial. All right, so in your study guide, on the back part, you see right here? It says multiply a polynomial by a what? Monomial. And then remember to get rid of the parentheses, you're going to use what property? Distributive property. So that's this one right here. Okay? So you're going to, where it says study class notes, I'm talking about this. Because I didn't give you a worksheet on it. All right, so all you do is think about, and you can write it out, or you can think about it in your mind. Most of you can probably do this in your mind, but you're going to say 3x times what? 4x squared. All right, so what's 3x times 4x squared? 12x to the third, good. Now the next one's, now remember, this is subtraction here, so you're going to think of this as a positive times a negative, which is a what? Negative. So it's 3x times 7x. Come on, finish it. Don't just say negative 21.
21x squared.
Okay, because x times x is x squared. And then what's 3x times that positive 1?
It'd be 3x.
Plus 3x. And you're done. Good? Can I combine any of those three terms? Or which ones can I combine?
12x. No.
You can't combine any of them. They all have different exponents. Remember, like terms are terms that have the same variables raised to the same exponent. They're all different. This is a 3, this is a 2, this is a 1. All right. Now, what if you had this? Suppose you had 1/3 x times 9x to the third power minus 6x squared plus 3x minus 1. So 1/3 times 9x cubed minus 6x squared plus 3x minus 1. So again, you have a polynomial times a monomial. 1/3 x is your monomial. You're going to get rid of the parentheses using distributive property. So you may need to write some things out. So you have 1/3 times 9, right? What's 1/3 of 9? 3. But you also have x times x cubed. What's that? X to the 4th. So now I'm going to ask you, what is 1/3 x times 9x cubed? 3x to the 4th. Okay? Now, a positive times a negative is a negative. So what if you had, well, the next one, what's 1/3 of 6? 2. But what's x times x squared, though? X cubed. So what's going to be this term? 2x to the third power. Okay, what's 1/3 of 3? 1. But what's x times x? X squared. So you're just going to say plus x squared. Don't put the 1. It kind of, remember, it's understood to be a 1. All right, now the next one. What's 1/3 x times, first of all, positive times a negative is a negative. So you're going to be subtracting that term. What's 1/3 x times 1? Anything times 1 is itself. So what's 1/3 x times 1? 1/3 x. Right, so there's your answer. Okay? Now what if you had this? Negative 1/7 x cubed times 14x squared plus 7x minus 2. All right. So you have this trinomial, this polynomial being multiplied by that monomial, but it's a negative times a positive be a negative. Okay, right. So think of 1/7 times 14. What's the 7th of 14? 2. But what's x cubed times x squared, though? X to the 5th. That's the product rule. When you multiply like base, you do it to those exponents. You add them. So it'll be negative 2x to the 5th. All right. A negative times a positive is a negative. Now what's the 7th of 7? And what's x cubed times x? X to the 4th. So minus 1x to the 4th. All right. Now, over here, you have, well, first of all, a negative times a negative is a positive. So what's 1/7 times 2? 2/7. Good. So now I'm going to ask you, what's a negative 1/7 x cubed times a negative 2? A positive what? 2/7 x to the third. Okay? And so that's all that is. All right. So that's 10 points. All right, 10 points. Okay? All right. So you are going to have, just like the study guide said, you are going to have a, and they always have this, it's always a polynomial times a monomial they have. All right, and it's usually something with a fraction in it. All right, so make sure you focus on these two. All right, now, the other thing you got to be able to do is multiply binomials using FOIL. You may remember FOIL, the word FOIL, first, outer, inner, last. Okay? It's not that difficult. All right, listen to these words. All right, so you see here, you had a polynomial times a what? What's the one you just did? Oh, I see what you, okay, I see. You were talking about, I'm looking at this and you're looking up here. It's a polynomial times a monomial. To multiply that, you use what property? Distributive property. Okay. What if you had this? What if you wanted to multiply, and let's say you had 3x plus 2 times 7x plus 4. So notice you're still multiplying polynomials, right? Just like you did here. Here you're multiplying polynomials. Now remember, poly means many, but a monomial is still considered polynomial. So you had a polynomial times a polynomial. All right. Here, you are multiplying polynomials, except they're both what? Binomials. So the quickest way to multiply two binomials is use a FOIL method. It only works for, the FOIL only works when you're multiplying two binomials. F-O-I-L. So F stands for first, F-I-R-S-T. O stands for outer, O-U-T-E-R. I stands for inner, and L stands for last. All right. So when I say first, though, I'm talking about the fact, now remember this operation right here, what am I doing to those two binomials? I'm multiplying them. So that first means I'm going to take the first term in that first binomial, which is what? 3x, and I'm going to multiply by the first term of that second one, which is what? 7x. So what's 3x times 7x? 21x squared. Okay, so that's my F. That's my first. Then the outer means this. You're going to look at this expression you see here, and you can look at the terms on the outsides. What terms on the outsides? 3x and 4. So it's 3x times 4. 12x. Inner means, so for outer, if you looked on the outside, inner means to look on the what? Inside. So it's 2 times 7x. 14x. And then the last, so remember the first versus last. So first meant look at the first terms of each binomial. Then last means look at the last terms of each binomial. So what's the last terms of each binomial? 2 and what? 4. So what does that give me? 8. So when you multiply two binomials and you get rid of the parentheses by using FOIL, you end up with how many terms do you see? 4. Now you got to ask yourself, can I combine any of them? Yes. Which ones can I combine? The middle two. All right. So when I combine 12x and 14x, what does that give me? 28x. So my answer is going to be what? Well, let's put in descending order. 21x squared plus 16x plus 8. There's your answer. I'm sorry. I'm just writing what someone told me. What someone said. Without.
I might have said 26. I'm sorry.
Yeah, you know, at Destiny, you take everything Destiny says, you write it down. That was a mistake. 12x plus 14x is what? 28x. 26x, I'm sorry. 26x.
Sorry guys, it's my fault.
I know, it is. All right, let's do this example. Suppose you had 5x minus 2 times 6x plus 1. All right, so you're multiplying two binomials, right? So in your final, you're going to, and they always have this, you're going to multiply two binomials using FOIL. Because you have to know FOIL for next semester, because most of what you do next semester will be factoring.
Are you gonna say it on there, like, so we'll know that we'll be able to differentiate between these and the other ones?
Say it again? What was that?
Is it, so we can differentiate, like, is it gonna say? use
No, it's going
all
to, no,
four?
it's going to say perform the indicated operations. So you have to know that if you have a polynomial times a monomial, you're going to use what? Distributive property. If you have a binomial times a binomial, you're going to use what? FOIL. Okay? So make a note of that.
Mr. D, do you think next semester in 99 that it'll start with the graphs, the graphing stuff, like the new stuff we learned
Usually,
this semester, is it gonna pick up?
there's the first week involves reviewing the graphing part. So that's it. Yeah. And then as you go through the factoring, usually they'll review like FOIL, things like that.
I'm hoping I can get it the second time around.
Get one second. Oh, you mean this?
Well, yeah.
Yeah.
graphing.
No,
I'm
right.
hoping that it'll, because when I told you no teach, you need to slow down, is because that was new stuff. And if I just had more time with you, then I'd be able to
Right.
get it in there.
Huh? I understand.
I mean, get.
All right. Yeah, we're all right. Come on. So on the test is going to say perform the indicated operation. So when you see this, you're going to use what method? FOIL. Now, to be honest with you, FOIL is a version of the distributive property, but you're going to use FOIL. So FYL. So let's do F first. So to do F, I'm going to multiply which two terms?
5x and 6x,
All right, what do I get?
30x squared.
30x squared. Okay, now the outer. That's going to be multiplying what terms?
5x.
What do I get? 5x. Now the inner. Negative 2 times 6x is? Okay, now the last. Negative 2. Do I stop?
No, you combine.
No. So when you do the FOIL, remember FOIL only works with two binomials. When you multiply that out, you're supposed to get four terms. Most times you can combine them. And I can combine these two. Come on, guys.
30x squared minus 7x minus.
Okay. All right. Okay, now what if you had this one? 7x minus 3 times 7x plus 3. So it'll say perform the indicated operations, or it could say multiply. But to do that, you're going to use what method? What method? FOIL. All right. So F, 7x times what?
7x.
Is?
40 minus x.
Okay. Outer, 7x times what? 3 is? Okay. Inner, negative 3 times 7x is a negative 21x. And then the last, negative 3 times positive 3 is negative 9. Combine like terms. What do you notice about those terms you're going to combine? Yeah, so they add to be 0. So your answer is only going to have how many terms in it? 2. What are they?
9x squared minus 9.
Yeah, because this turns out to be 0, right? Okay. All right. So you're going to have two binomials just like this, and then you're going to see something like this. So let's see if you remember this idea. So if you have negative 6 squared, so the base here is negative 6. The squared means I do what to that base negative 6? Multiply by itself how many times? Twice. Now, negative 6 times negative 6 is a positive 36. Some of you, a lot of you in that worksheet you turned in that you got back, you would have written it as a negative 36. And I think because you're putting it in your calculator. So when you put it in your calculator, if you put negative 36 squared in your calculator, it is going to give you negative 36. But it's not negative 6 squared that the way you put it in your calculator. You're supposed to put negative 6 in what? Parentheses. And then you square it.
I kept getting that confused. Which one?
Because there is a difference between these two.
Parentheses and out of parentheses.
Parentheses, not parentheses. So if in this one, the only thing that's being squared is 6. Here, what's being squared? Negative 6. So here, the only thing being squared is 6. So that means 6 times 6 is what? 36, but it is a negative 36.
That's outside of the parentheses?
There is no parentheses here.
Right, that's what I mean. So when there's no parentheses, you keep.
The only thing
sign.
being squared is that number. The negatives on the outside.
Okay, so is the base considered negative 6?
No, the only thing, you talking about this one?
Well, just now you said the base was negative 6.
Here, the base is negative 6.
But on my paper, I had a negative and you circled it and said the negative wasn't part of the base.
Because here, the base is only 6. That's the only thing being squared. It's not in parentheses.
So what would be the base on negative 7 squared?
7. You put negative 7.
Right, so,
7. What's being squared? Negative 7 or 7?
okay, so when it's in parentheses, the base would be,
The base is what's inside the parentheses. Okay? There is no parentheses here.
the parentheses,
Okay. All right, now let's look at this. What if you had 2x minus 5 squared? As I say, perform the indicated operations. So 2x minus 5 squared. What's being squared? 2x minus 5. That binomial is being squared. What does that mean? 2x minus 5 squared. It means 2x minus 5 times itself. That was the reason why we referred back to this a while ago.
so would it,
So that means 2x minus 5 times itself. And now you're going to use what method? FOIL. Okay? So on your final, and they usually have a binomial squared because you're going to need that idea next semester with the factoring stuff. So you have that binomial squared, you rewrite it as that base times itself, and now you see that you would have to use the FOIL method. So what's f times f? Thank you. When I said f, I meant first times first.
can you make that a little bit bigger?
I meant
Okay, the white skirty, but
all right. What's the outer? Negative 10x. What's the inner? Negative 10x. Now, what you need to see at this point, and we don't have time to really talk about this, but what you need to see is that when you square a binomial, the out and the inner are going to be the same term. Okay? When you square a binomial, the out and the inner are going to be the same term because the binomials are the same. So the out and the inner are going to be the same. You see they're the same? All right. And then what's the last? What's the negative 5 times a negative 5? Positive 25. And now combine like terms. 4x squared minus 20x. Good. Because a negative 10x and a negative 10x is a negative 20x. Plus 25. Okay, let's do one more with this. All right, suppose you had 4x minus 2 squared. Okay, so you say 4x minus 2 times what? 4x minus 2. That's the first thing you need to do is write it out so that way you can see you're going to use the FOIL method. Now use the FOIL. What's 4x times 4x? Nope. 16x squared. What's the outer? Negative 8x. What's the inner? Negative 8x. And what's the last? No, a negative times a negative is a positive. Positive 4. Don't lose any points now. Those are easy ones to get. Those are 10 points each. All right. No one should be missing those that we're talking about right now. Adding, subtracting, multiplying distributive, multiplying FOIL. Those are 40 points you need. Those are 40 easy points to get. Okay? All right. So what's the answer? 16x plus 4. All right, so that's 40 points that all of you can get. Okay? All right, so that takes care of 4 of the problems. All right, now, they're not difficult problems. And that's why I waited until the end to do the polynomials and went straight into the equations, because the equations are harder for students than polynomials. Okay, now, so let's go back to that back page of your study guide. So you can add and subtract polynomials, right? Okay. You can add and subtract polynomials, correct? This one here? Yes or no? Okay. You can do the one that says subtract from, right? All right. You can multiply 2 binomials using FOIL. Okay. You can multiply a polynomial by monomial. Yep. And it was the first thing we did. The first thing we did was I can't remember the first thing we did. All right. Oh, it was okay. So subtract polynomials. Then we did a binomial. Oh, that's right. So this right here, where you were using FOIL, there are 2 problems. One is where it's already written as 2 binomials multiplied together, and one is where you had the binomial squared. You have to write that as what? 2 binomials. Okay, so you see the 2 problems? Okay, so that's 4 altogether. That's 40 points.
I like the second to last one like we just did.
All right. Okay, now, a couple of things. Before we look at the other 2 stuff right here, before we look at that, there were a couple of things I need to remind you. Okay, so that takes care of the polynomials for right now. All right, so what I'm going to do now